Hello, my name is Lars. I work as a product owner on our QC platform, and I want to make a small presentation of what kind of product it is. It's built around two platforms. So the one is for uploading images and annotating the images of what you want to find, and then do the actual training. The output from this software is then fed over to a runtime software. That is what you can see here. And here is a software that controls all the cameras that is connected to a setup and gets all the images from there. And then it applies the model that you trained in the previous software on these images to get a result. And as you will see on this example that we have is wood, where we need to find cracks and these knots on the wood. Here we made a very simple training where we collected like 20 images and then we annotated each knot and crack on it. We trained it for about half a day, and this would be the result you get. And you can see here that it finds the knots, and also if you turn it around, we will have a crack on the side that it will also find. And also for the fun of it, we actually made it should also find these rough areas on the wood. And here we show that with a very few examples of this, we can actually get the AI to find this. In this example, the information or the results from the AI is used to locate these knots and cracks on the wood. And this information can then be passed on, for example, to a robot that could then put in some filler into the holes so they can process it by sanding and then make it ready for painting in the next step. Another example that we can choose is to find defects in parts. And here we have some metal parts that is very small. And on this metal parts we actually use up to 12 cameras that each take 2 images. And then based on all the results from all the images, we are getting a final result on the product. So is it okay or NG? And here we have a lot of different types of defects we are looking for. It could be a crack, it could be a dent, some miscoloring areas. And if it is needed, you can sort it into different boxes. So for example, you have a box for all your cracks, you have a box for all your dents, and then a box for all your OK. And this way you can actually see in your system or your production what kind of errors you're seeing the most of. A very important part of our software is that we can do some post-processing on what the AI finds. So when you actually have found a crack in your part, then you can sort it by sizes. So it could be that the crack should be within a certain size in order to be OK or NG. But you could also have it in a specific location on the part that the cracks will be OK to have in the corner, but it's NG if it is in the middle of the part. So this is a very important part to fine-tune your system so you can make the right output. So you don't have to find only defects in your product, but you can also find features, required features. So for example, here we want to make sure that all the screws are located in the right position, but also that they're actually there. So here we can count, there is for example 10 screws, and if some is missing, we can tell that to the operator and they can put it back to repair and then feed it back into the QC platform. Another good example of how to use our system is to find features. So sometimes you want to find that you have a certain amount of screws in a part. So here, for example, I have the part where I need to find 10 screws, for example. And if one of them is not there, we can say, okay, we only find 9 and give that feedback to the user. And in this case, they actually use that information to recycle it back to the production side, and then they could fix it and then go back to the QC part, and then it will get approved when you have to put in the missing screw. What makes our software different from others is that we try to make a complete solution. So that is going from collecting images to annotate images to the training and to the final setup where you actually run it in production. We have the whole pipeline in this area, and that is what makes it easy and nice to go to our software. And also that we have in the end, we have this post-processing where you can fine-tune your system. Is a very important aspect in making a nice, good solution for the end customer. Some of the more interesting areas that we are looking into in the future is to how to generate fake data. We see this is a very common problem that productions are so good so they will not generate enough data for us to train on. So in order to help with this, we will use another AI to actually create scratches, dents, knots in the wood case, for example, so we can have a strong and good AI for finding this stuff. And if it's not important to find defects or features, but it's just important to know if something is wrong in the part, we can actually train on what we call OK data. So that means you don't need to find all your defects or in your production, but you can just collect some OK data and train on this, and then the AI will just tell there's something wrong in this corner. I don't know what it is, but I know there's something wrong. And this is much easier to train on because you don't need all the NG data, and therefore you can get to a faster solution in the end, which is really nice. Yeah, so we are in control of the software. So we are a software company that create this vision-based software solution. So it's important that everything around it, so all the mechanical stuff, is something that is made by the integrator or the OEM that is actually having the need this implementation. We have made a lot of interfaces for our software. So usually we would have some sort of PLC where we use the Modbus connection. That is very common and fits usually many PLCs around the world. Another approach would be to use a TCP IP socket. That is also a very common interface. But here we can publish all the results from the detections. And then it's depending on what kind of solution you are looking for. You can choose which method you want to communicate with. So there are many approaches to this one. You also have cases where they have used robots. So you have the camera mounted on the robot, and then you move the robot around to take images. And this gives a lot of flexibility in this one. But if it's fast cycle times you're looking for, then a specific system is very important in this one.